Okay, awesome. Cool. Well, thanks everybody for joining. This is definitely a first time I've been a part of anything like this before. So hopefully it'll go smoothly. I wish I was more technologically inclined than I am. So you may have to put up with an old person like myself fumbling with some of the Zoom technology. But anyways, for the sake of time and to make sure that we have time at the end for questions, I'm just going to kind of dive right into the presentation that I have. So I'm going to share my screen here. All right. Cool. And so I've lost the comment bar on the side. So Kristen, if somebody has a comment or something, just interrupt me at any time. That's totally fine. Cool. Yeah. So before we get to Q&A and talk about Dear 139 or more about the research that I'm involved with, I kind of wanted to give everybody a little background of the research group that I'm a part of at the Monteith Shop, and then highlight some of our research in the Wyoming Range Mule Deer Project, that's the research project that Dear 139 is a part of, and is really serves as a good example, at least in Wyoming, of how research can really inform management and conservation and on the ground action to conserve wildlife species. So real quickly, who we are. So I'm a part of a research group. We refer to ourselves as the Monteith Shop. Generally, research groups refer to themselves as labs, but we call ourselves a shop, not because we sell things, but because we do really hands-on work, and a lot of our research is focused. It's very field focused. The Monteith Shop is a part of the Hobbs School of Environment and Natural Resources, which is then within the University of Wyoming. And really the point of a lot of the research that we do is it's to advance science and management of our big game species throughout the West. And so we have a pretty big team of folks. Here I just have some of the key players that have been a part of the Wyoming Range Mule Deer Project, either currently are a part of it or have contributed to it in one way or another in the past. And all of the research that I'll be sharing with you guys today is stuff that all of these people, Taylor, Rhiannon, Ellen, especially, research that they've done in understanding mule deer migration in the Wyoming range. So to get things started, I'm sure hopefully all of you are familiar with the scientific method. I think it's something that generally we learn in middle school, maybe even elementary school, but at times I think it seems like it's kind of a forgotten craft among some folks. And so, you know, I'll just quickly go through it. With the scientific method, you know, you have an observation. With that observation, you construct questions that sort of answer, or that you want to address to better understand the observation. You then construct hypotheses that you test to find support for or not, or support for or against the hypothesis. Then you have your approach or your experiment, followed by your analyses, and then your conclusions, which in the scientific world, you know, this is sort of built to be kind of a circular system. So once you come up with your conclusions, science is designed so you're constantly readdressing or questioning those conclusions again, really just to better advance it and refine our understanding of things. And although this is like the classic method, this circular method, as you can tell, it's just that in science, it's just sort of in this framework, it just feeds itself. But science doesn't really have any value unless it's applied to something, or unless it's put within a context that's meaningful for us and for our environment. And so a major part of this idea of the scientific method that I think a lot of researchers are now understanding the value in it and really investing time into it is the communication component to it. So taking our science, taking it outside of the ivory towers and outside of the world of academia and the scientific community, and communicating it to other people, other audiences, because really that's the only way we can have informed management and policy and even stewardship on the landscape that's spearheaded, you know, by the people, by the public, as opposed to just scientists living in their own world. And so, you know, why is research such an important part of this management, like doing management and conservation and coming up with policies? Well, honestly, I mean, like with anything, if there's an issue, the only way to fix it is to understand what the issue is. So just like with a car, if there's a problem with it, you want to figure out what's wrong and you want to address the issue where it is, where it's occurring, and fix it that way. And although I really appreciate the ingenuity of this fix to a broken air conditioner in a vehicle, it's probably not the most efficient way that somebody could fix their vehicle, and may not last all that long. And so really it's, you know, I think this speaks to the importance of getting down to the root of the issue and addressing it exactly where it's occurring. And so this same concept applies to research and management. And so if we think of an issue that we're dealing with not only in the Western US, but throughout the West and even, or throughout the US and even across the globe, is we have landscapes that are changing at a really unprecedented rate. And wildlife are in general really struggling to keep up with these rapid changes to the environment and to their landscapes. And Wyoming is no exception to this. And so, mule deer in Wyoming especially are no exception to this. Throughout the last few decades, populations of mule deer statewide have declined. Since 1991 to 2016, there was an estimated 31% decline by Wyoming Game and Fish. And within that is the Wyoming Range Mule Deer Project that also, or the Wyoming Range Mule Deer Herd that have also declined during that time. And you can see this figure is a population estimation of how the population fluctuates year after year. And in the late 80s and early 90s, mule deer were pretty abundant in the Wyoming range. And then right around 1992, 93, that population took a pretty big hit, pretty big crash, and it hasn't really been able to rebound back to what those historic numbers are. And so because of that, really, this is the observation of the declined population. And so it really raises the question, well, what is contributing to that decline? What's affecting this population? Why can't it bounce back to what it used to be? And so the Wyoming Range Mule Deer Project is a pretty comprehensive ongoing project that started in 2013 that is designed to address that exact question. What regulates the population, and what is preventing it? What is preventing it from rebounding to historic numbers, and also what even promotes population growth? What grows mule deer, basically? And within this project, we have a number of hypotheses and questions that we're addressing that are all different aspects of ecology of these animals, ranging from the effects of disease and winter severity. We're also evaluating the ecology of male mule deer, how they may differ from female mule deer. We're evaluating, or have evaluated, how energy development affects these animals, as well as, predation and how it affects fawn survival.
Sam,
and also,
from the chat real quick.
Okay.
So is taking the highest 4 years and the 40 years as the comparison statistically valid? So how do you know that's a good comparison and that you're not cherry picking when you talk about historic highs?
Yeah, no, that's a good question. It could, I mean, within that figure, that figure doesn't go back as far as the populations necessarily do. And so in general, there has been, there's a belief that populations have just declined in general and aren't what they used to be in the like 50s and even before, when beyond when that figure, beyond the window of that figure. One thing with it is that although the Wyoming range mule deer population, you know, according to professionals and their observations, it's believed that it has been in this constant depressed state since the late 90s. It generally is kind of like bouncing back and forth, and we aren't actually seeing a consistent or persistent decline there. There are, however, other populations within the upper Green River Basin, like the sublet population, where we do actually have longitudinal studies, so that's tracking year after year, 15 years of research in one of the herds in particular, the sublet herd, that has shown that coinciding with habitat loss, we have been seeing a pretty marked decline in deer there. About 36% of those animals have declined. And so that's more of, that is statistically validated in that it basically, it's running a trend line across what's happening and not isolating year after year. But I will say, I think that is a good question, because, you know, with everything science related or even management or conservation related, we have to try to separate anecdote from the science, or anecdote from empirical data. And by empirical data, I mean basically the results of science, things that have been tested and you know, have support for by going through the scientific process. And so with some of these issues, I think that's always something that we have to keep in the back of our minds. Ultimately, questioning like, okay, this is the source of information that I have, but this is the data that I have to support it. And really, when it comes to, at the end of the day, it's the data that are going to be the most useful and most informative for understanding what's going on. Sorry, I don't know if that helped, but that is a very good question, because yeah, data can, well, I'll just leave it at that. That's a very good question. And so I'll continue on here. So although it appears that these populations are not rebounding to believe what, you know, historic numbers, we're trying to figure out why that is. So anyways, Wyoming Range Mule Deer Project, we're looking at a number of things, and migration is one of the main, one of the many focal points of our research. And so how do we collect these data? Well, our approach here is really, we use what's called individual-based longitudinal research. So what that means in a nutshell is we follow individual animals. We track with GPS collars where they go, what they experience on summer range, winter range, and during migration. And we relate that all back to their nutritional condition, or sort of a assessment of their health. And we use ultrasonography to measure fat, and that's used as our proxy for more or less the health of these animals. And with that, we can then understand how the different environmental conditions that these animals are encountering, how they're affecting the individual animal, and how that influences their ability to reproduce and survive. So I have a little video here that it shows basically what our research approach, what it is. So basically it goes through our methodology of how we capture animals and collect the data that we do. So watch the video, and basically if not, you can check it out later. But you know, to summarize it, you know, we catch these animals twice a year, and we measure their body fat as they enter winter range. And then as they're leaving their winter range, we recapture them and measure their body fat, as well as evaluate pregnancy rates. And that allows us to, again, understand the contributions of the different winter ranges and the habitats they encounter during winter and during summer, and how that contributes to their ability to be able to reproduce and survive the course of a winter. And so really, when it comes to migration, one of the critical pieces of data that we collect from these animals lies in the GPS collar data that we get from them. So each of these animals are equipped with GPS collars. And now, as you can imagine, technology is such where we have some pretty incredible information right at our fingertips. I mean, case in point, we're Zooming right now across the US, which is kind of insane. But anyways, these collars that we put on these animals, they have satellite uplink, and it allows us to almost on a live basis track where these animals are going, and really get these good comprehensive maps of where animals are migrating, where they're using their different or what kind of habitats they're using along their migration routes. And so some of our findings, and I'm just going to kind of go through and highlight some of our main findings with these GPS data that we collect. You know, one thing is, and I speak to this is kind of a major theme in Deer 139, but we know with these data and with this information that these animals have incredible fidelity to their migration routes. And so, you know, they're following the same migration routes year after year. And so this figure here on my left, I just highlighted just a few animals. I just grabbed a few animals at random, and these are Wyoming range deer, and have 1 year of migration is the dark, each color is a different animal. The darker hue is the first year of migration, the lighter hue is the second. You can see a lot of their migration routes overlap pretty dang closely. And then, you know, this research has also been done in collaboration with other folks in Wyoming, with Paul Sawyer and his colleagues, where you know, we're seeing these trends in incredible fidelity to these migration routes kind of across the board. So here's a figure of 6 years of migrations, and you can see those lines are so tight between those two animals that were just highlighted to illustrate how closely they follow their migration routes. Now, also, we, you know, in addition to just seeing how they have such fidelity to it, but we also can use these data to evaluate, well, how important is migration for these animals? Like, is it, you know, it's essentially not just a act that, or a behavior that gets them from point A to point B, but there's actually quite a bit of nutritional value in their migration routes. And we see this because we've evaluated how mule deer track the newly emerging vegetation as it greens up across an elevational gradient. And they're doing this at a time where they essentially, arguably, may need it most. They're coming off of winter ranges where they're in the worst condition that they'll be in, and they're just about to embark on giving birth, which is definitely the most energetically costly thing that they'll experience. And so some of our research here that I want to highlight is how not only that we've identified that mule deer are really, really great at tracking the green wave or surfing the green wave, but they also, their ability to track the green wave is affected by climate. And in dry years, it's harder for animals to track green vegetation versus in wet years. And so here's an animation that I think articulates it well, where the green spots represent vegetation at its peak nutritional value. So like right when it's shortly after it's emerged and when it's most nutritious for these animals. And in dry year, what happens is that pulse of green up happens all at once, and it doesn't happen in a nice wave, so it's harder for animals to track. So here we go. This is a time lapse starting in April, and all these dots are basically mule deer migrations that are following the green up. You can see in the dry year, it's all green at that point, and in the wet year, it's still a nice mosaic and still a very gradual green up that's happening. And so those numbers at the top are tracking scores that we give these animals. So an animal that's perfectly tracking the green wave gets a point, or gets a score of 1. And then a terrible tracker is a 0. And you can see in a wet year, animals are much better at tracking green up as opposed to dry years. Now, in addition to evaluating what it means for adults, a lot of our research is focused on what's happening to the offspring of these animals. How, because the offspring or the young of a population are really what can promote population growth. And to understand what might be hindering population growth, you kind of need to understand what's happening to the young. So within our research, we also have, we're studying the ecology of multiple generations of these animals. Again, capitalizing on the amazing technology that we have. These GPS collars, they can be Bluetooth wired into a device that we put into pregnant animals in the spring. When that device is expelled, it sends a signal to mom's collar, which then sends a signal to a satellite that sends us an email that gives us an exact location of where these fawns are. And then we can go to that location and, really if we can get to the animal within 2 or 3 days, we're able to find that fawn and put a GPS collar on that fawn as well. And so with this information, we can not only just track fawn survival and what contributes to it, and essentially evaluate how, there are a whole suite of things that can kill fawns, and it tends to vary from year to year. In addition to evaluating, what the relative effects of disease and malnutrition and predation are on these animals, we can also actually see how young are learning migration from their parents. And here's an example of one animal that I think is a good example of young that did learn the migration route well from its parent. And then, we do also have some that don't learn it quite as well, which is pretty interesting. But anyways, I'll highlight this one here, F205. So this is the first migration that she had, going from her summer range up on the north or top end of that map down to her winter range on the south end. And you can see this is her first migration with her mom. Her second migration, this is both fall and spring migration here. She follows nearly the same path. And even in her third migration, follows nearly the same path. And this is pretty typical that we see. However, we do see that some of the ways that these animals learn these landscapes isn't necessarily by mom alone. We have recently discovered that mule deer have this incredible capacity to learn their spatial, or to learn their landscape at a rapid pace. They have spatial memory that's probably way better than any of us. They don't use a GPS the way we do, yet they can navigate these really complex landscapes. And so what we see here, this is the story, the really amazing story of F210, where, as a yearling, she migrated up to her summer range with her mom, and got to that summer range. And usually yearlings get kicked off when mom is ready to give birth to her next offspring, or to her next fawn. She'll kick off her yearling, and can actually be pretty aggressive when it comes to it, because mom basically wants to be isolated when she gives birth. So anyways, mom kicked off F210, and in what I believe to be kind of a rebellious fit, F210 took this crazy walkabout where she ended up navigating 59 miles just one way. And over the course of this walkabout, went over 24,000 vertical feet. And the most amazing thing about this journey is she went on that walkabout without her mom, and got to her destination and almost immediately turned back and followed nearly the same route back. And that, again, is just speaks to the incredible spatial memory and ability for these animals to collect information so rapidly.
Emma, I had a quick question from the chat for you.
Yeah.
Are the GPS collars that you guys put on the fawns designed to break open or enlarge as they get bigger?
They are, definitely. Yep. So they're basically designed to do both. So they have stitching that as the animal grows, the stitching becomes undone. And it actually, it's really great that it does that. Sometimes it can hurt us as far as collecting data, because animals can get it caught on a fence and then it'll just rip the whole collar off, because they're meant to be made really flimsy. And then after about a year or so, the collar will eventually just break off because the material is made so it does that. But what we do is again, since we're recapturing these animals year after year, we can recapture these animals as a yearling and fit yearling collars that we have that also expand with their growth. And then we recapture them again when they're an adult, and we can fit an adult collar on them. So we're always adjusting, the collar technology, obviously, to the animal and what's best for the animal, what's most comfortable for it. For example, for bucks, we have expandable collars. So when bucks are undergoing rut, their necks swell like a crazy amount. And so we need to have collars that expand with their swelling necks. Now, shortly after rut, their necks shrink again. So we need a collar that will retract back and fit tightly or nicely, snugly around the neck. And so we have collars that do that as well. So yeah, finally, I just kind of want to speak to this is kind of the last little bit of research that we have that I think is pretty cool and pretty cutting edge. So, I think, as demonstrated with our other research, animals are relatively rigid in where they go during migration, but they have a bit more flexibility when it comes to the timing of their migration. And so what we see is that mule deer are essentially timing migration almost perfectly for being able to get to their summer range just shortly after all the green up has happened, and get to their summer range when it's in a condition where they know that there's good vegetation for them. And so in this figure, each of those lines represents a different year. And within these years, we've had an incredible variation of snowpack and when snowpack has melted away. So we have some years where snowpack in the higher elevations melted, as early May, and then other years where it didn't melt until late June. But you can see that despite the variation in the snowpack, animals are basically they're timing their migration, either timing when they depart from winter range, or could be in combination with also taking longer to get to their summer range. And in doing that, they're able to time it so they're getting to their summer ranges really about 2 weeks before they actually give birth, which I think is pretty cool, because really what all of our research shows is that these animals are so well evolved and well adapted to migration and even their specific migration routes. And really, migration is truly a fine-tuned machine for these animals. So, then this kind of brings us back to, okay, how does this apply to conservation? Well, we do inevitably have issues. We have barriers to migrations. Migrations, these animals are migrating over landscapes that have have been altered substantially in some situations. And there's lots of research from colleagues of ours and research from other folks throughout the US and really throughout the world that have shown that, indeed these human-induced landscape alterations can either totally sever migrations. In the case of, for example, the I-80 corridor, there's evidence that it's totally severed historic north-south migrations of pronghorn. Or it can make migration difficult for these animals. For example, fencing can change the way that animals move across their historic migration corridors, and energy development. There's quite a bit of research out there showing that animals not only avoid energy development if it's been placed along their migration route, they'll alter their migration route to avoid it. But also they increase their movement rates through energy development. It might alter that timing that they have for tracking the green up the way they need to, and also the timing for arrival to their summer ranges. So, we have these issues, but again, we can use communication to come up with ways of mitigating the effects of these changing landscapes for these animals. And so I just really want to finish with some of the efforts that have happened that I think we can really applaud the state of Wyoming in particular in taking action and helping conserve migration corridors. So again, these efforts, in order for them to happen, they really require communication, and communication beyond just to managers and politicians, but also to the public. And so, we have collaborated quite a bit with a number of folks, various state agencies, as well as nonprofits, and organizations like the Wyoming Migration Initiative to really get our information out there. And so some of the examples here, public engagement, partnering with organizations like MULE Fanatics Foundation and going to their banquets and communicating our science with folks there. Creative storytelling like Deer 139, trying to get our stories out to new audiences. And then, social media now has become a main form of communication. Both, we've collaborated with Wyoming Migration Initiative in getting our stories out, but also we have some of our own social media efforts. And finally, just working directly with managers and NGOs that can implement the science that we have to inform their practices, or even for certain NGOs like Wyoming Outdoor Council, who can take our information and bring it to politicians and really help use it in forming policy that's effective for wildlife. And so some of the outcomes here, especially in policy in Wyoming, that I think is pretty great, is you can see these data here in this map are our data that we collected from Wyoming range mule deer. And these have directly gone into informing policy aimed at protecting or conserving migration corridors. So migration corridors in Wyoming are now, they're designated as habitats that must undergo greater restrictions when development or anything is happening along those lines, any kind of landscape change. And so here's a cool map of some of the migration corridors that have been designated or that are being proposed for designation. And so I think this map is really cool because it really just illustrates how important having the information, the GPS data, where these animals go, how important it is for making these policies happen. And so, like for example, here is a high use corridor of the migration route. And this is the corridor that 139 takes. This is exactly where she goes, and this is a drafted area for as a designated migration corridor. And so, yeah, I encourage folks, I can send at the end of this, I'll send this link out. I encourage folks to play around with this because I think it's pretty cool what they've done there at Wyoming Game and Fish in showing that. Also, there's been a lot of efforts in building, you know, wildlife crossings, safe wildlife crossings, Trapper Point here being one of them. And there's a video here that I'm not going to play because clearly I know videos don't work. But they're a cool initiative that's happened throughout the state. And again, I'll send this link afterwards so folks can play with it. Is based on data from both WYDOT and from GPS data. We have all of these areas along various major roadways throughout Wyoming that have been sort of earmarked as places where, hey, these are folks where we should, or these are places where we should focus any kind of safe wildlife crossing efforts. And so one of them I want to point out here is along this dry piney corridor where you can see mule deer and pronghorn are believed to benefit from putting overpasses or underpasses in this area. And so with that, there's great news. WYDOT received a $14 million grant to construct overpasses and underpasses alongside that road. And this map here shows GPS data from Wyoming range mule deer where they cross the road. And this map here and these data directly went into identifying where these safe wildlife crossings are going to occur. And finally, you know, with sharing this information with audiences beyond policymakers or managers, you know, we really can use it to help promote stewardship. And I think a good example of this is where we see ranchers or, you know, private land managers who are replacing fences with wildlife friendly fencing so animals can migrate through, or even laying down fences so during migration so they can move through. Also, there are a number of nonprofits throughout the state that have pretty ongoing fence removal projects that are really aimed at removing these fences that are obsolete. And so with that, I guess we can go to questions such as, you know, why the hell do we have this giant bag of cheesy puffs? And really it's because that's what we use to fuel all of our brain power for this research. We clearly need lots of it. And, you know, if you also, if you have any questions that we can't get at today, we have both a website that you can visit here, the Ungulate Compendium, ungulateCompendium.org, or Instagram. You can definitely message us on Instagram at Monteith Shop. Definitely follow us if you would like. And then you can also email myself or our greater Monteith Shop, email address if you'd like. So
cool. So people can, just to be clear, folks can ask questions about any of the science you talked about today, but also about Deer 139 and maybe anything about what it's like to have the job that you have. So is it okay if we go with a little bit of a free-for-all? And folks, you can unmute yourselves to ask questions too now, since we're out of the presentation phase.
And I'll just answer the one question about if Game and Fish has moved to encourage smooth wire as a bottom strand on fencing. And yes, they have, that's a part of their recommended wildlife friendly fencing standards that they have for those fences. And so it includes smooth wire on the bottom fence, but also having that bottom wire being high enough so young animals and pronghorn can scoot underneath it, as well as the top wire being smooth and the spacing of the top two wires being wide enough so animals don't get their feet caught in the two wires at the very top of the fences. Yeah, and then also, how old is deer 139? She's coming on 7 right now.
And you guys caught her again last fall, right?
We did, yeah. So we actually just caught her this last spring in March. And believe it or not, she's pregnant with triplets again.
Wow.
Which is crazy. Yeah, it's really crazy. She was in incredibly good condition in December. She was like one of the fattest animals that we had, and now she's pregnant with triplets. So yeah, we're hoping that all of those triplets will survive this year, and she'll pass it on. We had lost contact with her, one of her fawns, actually the one that is captured in the little video at the end of deer 139. We lost GPS contact with that animal shortly after collaring it, but we just found it again, which is awesome.
Cool.
So we now have that animal is collared now and back in the study. I thought it had died because we lost contact with it, but indeed it did not, and it's still kicking it. So we've got a couple generations of deer 139 on air right now.
It's pretty great.
Yeah.
Looked like you had a question, so I'm going to unmute you.
What is the average survival rate of fawns, especially as the population is declining? How does that really affect the next generation? Is it going to decrease even more?
Yeah, that's a great question. So in general, about half of the fawns that are born in early summer don't make it to their winter ranges. In general, about half of them die. But mule deer are designed so they have really high pregnancy rates and really high fetal rates. So they're usually, like 98% of them generally are pregnant, and most of them are pregnant with twins. So even if they're losing half of those animals before they reach winter range, populations can still persist. Now, whether or not fawns survive over winter is highly variable. At least this is what we're seeing in the Wyoming range. We had a very severe winter where we lost all of our collared fawns. Basically, an entire cohort of fawns died because it was just an incredibly severe winter that we saw a bunch of adult mortality as well as fawn mortality. And so those events can happen, and that clearly affects the trajectory of a population, because that essentially wipes out an entire cohort of animals. But a cool thing, sort of the silver lining in that, is that when you see a population crash like that, and when you see a bunch of young animals die like that, usually the following year or a couple of years after, you see incredible growth of the population. So I don't know, in that population trend, the estimate figure, you could see there's a lot of this going on. Like there's, populations grow and they shrink and they grow and they shrink. And a lot of that is, following those crashes, oftentimes populations are able to rebound. And we see that a lot with our data, which I think is pretty interesting. And yeah, to speak to that figure again, one thing that we're realizing, and that we're gaining more and more data to support this hypothesis, is that the Wyoming range mule deer population, just in general, because of a lot of the landscape alterations that have occurred, that population has been, the carrying capacity of that population is reduced. And so the carrying capacity is basically the number of animals that a landscape can hold. And that fluctuates. You know, anytime you take away food or land from a population, you're essentially reducing a carrying capacity because you're limiting the number of animals that landscape can hold. And so we think, and we're again getting support for this, that the Wyoming range mule deer population has really just been, the carrying capacity is down low now relative to what it used to be. And now the population is just operating within that. And so it's not necessarily continually declining, but we're seeing these drops and increases, but all kind of capped at that now reduced carrying capacity of the landscape. Oh, Kristen, I think you're muted.
I do that all the time. Thank you. That was a really good question. So it looked like we had a question from Mia or Maya. Sorry if I pronounced your name wrong, but if you want to ask your question.
I was wondering if you just use ultrasounds to see how many babies the deer would have, like how you knew how deer 139 was going to have triplets.
Yep, that's a good question. Yeah, and we do use ultrasound. So it's just, I mean, basically how it works for people. We we ultrasound in March, so the fetuses are actually pretty big. They're maybe about that big, and they're actually big enough at that stage where we can measure the eye diameter. And what that does for us is it can help us helps us predict when the timing of birth is going to happen. Because the fetus, the development of the fetus, is different among individuals. It's influenced by not only when conception happened, but also the amount of fat that mom has. She can invest more of her fat or muscle into developing the fetus or not, depending on how much she has. And so in March, we can get that fetal eye diameter, and if it's a really big fetus, we know that it's probably going to be born pretty soon or early relative to others. Or if it's a really small diameter and a small fetus, it'll probably be born later in the summer.
Cool. Next up, we had a question from Lorelei. So Lorelei, I'm unmuting you.
Are you expecting this year to be a dry year or a wet year?
It's always hard to say, but right now it is looking like it'll be a wetter year. We've had some really great snowpack up high, and actually it's worked out really well where we've had lots of precipitation up high, but not as much precipitation down low on winter ranges. So the animals, when there's a lot of precip down low, that not only buries the food for these animals to access it, but it also, it increases their energy needed to just move through the landscape. I mean, they're post-holing through it when it's super deep snow on their winter range. So deep snow down low can be pretty bad for animals, at least when it comes to survival over the course of the winter. But the catch to that is when there's a lot of snow up high, that means that it takes longer for it to melt out, and there's usually a lot more production in vegetation. So a lot of grasses, a lot of forbs, and everything grow back with quite a bit of mass. And so it can provide more food for these animals. So anyways, we've had a lot of precip this winter, a lot of snow up high. And so I think I would predict that it should be a good summer for animals, but it is hard to say because who knows what actual summer will bring and what late summer and fall will bring as far as precip goes.
That's all the questions we have in the chat. Do folks want to unmute and ask any other questions? Sorry that you can probably hear my dog yelling in the background. Back when I was teaching, they used to tell us that we had to wait in silence for like 15 seconds after we asked if people had questions. So
What can be done to increase the carrying capacity of the landscape so we could have more deer?
Yeah, that's a really good question. And I think that's a pretty tough question. You know, one thing that a lot of management agencies do is habitat treatments. So identifying the habitats and vegetation that can be more beneficial to wildlife, and using treatments such as prescribed burning to help bring some of those habitats back. So, you know, for example, that can, by burning a conifer stand, you can help promote some aspen regrowth, and aspen can tend to be associated with some pretty good foraging vegetation for wildlife. There also, you know, a lot of the habitat loss, there is, on winter range in particular, there is a lot of energy development in a lot of these areas. And so the energy development, it kind of affects these wildlife in twofold. You have the direct habitat loss from just, you know, the construction of a well pad or a road. But then you also have what's called indirect habitat loss, which is basically animals avoid the human disturbance that's associated with that infrastructure. And so it ends up ballooning the amount of habitat that is actually lost to these animals, because there may be vegetation and good food near where infrastructure is, but animals don't use it because it's, you know, it's regarded as too risky for them. And so in those situations, some things that can be done to more or less increase the carrying capacity is, you know, minimizing the human disturbance, basically minimizing traffic and minimizing the cues that animals use to, you know, determine if a place is risky or not. And then also reclaiming a lot of those well pads where they're no longer in use, and you know, those scars can just go back to sagebrush. And there is a lot of the energy industry definitely implements a lot of reclamation in areas where development has occurred, and so that is happening. And they also are trying to actively use strategies and how they develop areas for oil and gas extraction. They try to concentrate it so there's less of a direct habitat loss. And then also there are regulations on when they can be drilling and trying to minimize the level of or intensity of human disturbance. So those, I think, are a couple of things that can be really beneficial.
Great. And unless other folks have questions, I'm just going to say thank you so much to Sam for joining us today. Thank you for persisting through probably inevitable in this like homework, homeschool era through technical difficulties on Zoom. So thank you. Thanks to everybody who came. Before we give a round of applause to Sam and say goodbye, I do want to put in a little plug for an event we're going to do next week over Zoom. On Thursday, we're going to have an all about wildlife diseases in Wyoming Q&A and lesson with Hank Edwards, who runs the Game and Fish's Wildlife Health Lab. So if you've ever wondered about all the kind of like gross things that happen to animals and all of the different diseases that bighorn sheep and rabbits and deer and elk get, Hank is an expert in all of that, and that's going to be a fun class too. So keep your eyes out for that invitation if animal disease is something that's interesting to you. And with that said, I just want to thank Sam again for her time. We'll be following up over email with some links and resources. I know a number of you had said you were interested in a follow-up assignment, and we look out in your inbox for that. So thank you so much to Sam. Thanks to everybody. Goodbye.
Cool. Bye, everyone. Thank you.
Thank you.
Thanks.